Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine teaching a machine not just to draw the world, but to understand it, to imagine what happens next, to respect gravity, to keep objects solid when you walk around them. That's the bold vision behind the paper, the Trinity of Consistency as a defining principle for general world models by the Open Data Lab research team. And this paper argues something powerful. If we want true world models, we need three pillars working together. Today's video models can generate stunning visuals. They look real, but they behave like naive physicists. Objects stretch, causality breaks, geometry shifts across views. The paper says the issue isn't scale alone, it's missing structure. We don't yet have a principled definition of what a general world model must satisfy. They compare discrete autoregressive token modeling with continuous flow matching. AR suffers exponential error drift. Flow matching keeps errors linear. That's huge for long generation. Second, spatial consistency. We move from 2D proxy manifolds to nerve-style implicit fields to explicit 3D Gaussian splatting. The world must obey geometry, multi-view constraints, epipolar consistency, or you get the Janus problem. Third, temporal consistency. It's not just smooth frames, it's causal evolution. They trace the evolution from frame interpolation to native spatiotemporal DIT models like Sora to causal reasoning and test time planning. The real shift happens when these axes fuse: modal plus spatial, modal plus temporal, spatial plus temporal. The paper describes how unified architectures like MM-DT use orthogonal decoupling to reduce gradient conflict. Then reinforcement learning and VLM as a judge create a perception generation feedback loop. Finally, test time compute introduces reasoning loops, tree of thought, MCTS, verified guided refinement. World modeling becomes search on a spatiotemporal manifold. Theory needs proof. So they introduce cow bench, consistency of world models benchmark. It evaluates single axis consistency, cross axis consistency, multi-frame reasoning, constraint satisfaction. Not just how pretty the output is, but whether the model truly understands world structure. What's fascinating, the authors argue that dissolving the boundaries between modality, space, and time is a prerequisite for internal simulation. Modal gives meaning, spatial gives structure, temporal gives causality. Remove one, and you don't get a world, you get a slideshow. The outlook points toward neurosymbolic grounding, action consistent world models, end to end native 4D streaming, models that don't just generate pixels but simulate consequences. It's a shift from probabilistic generator to general world simulator. This paper doesn't just review progress, it proposes a definition. A world model must satisfy the trinity of consistency. And maybe that's the missing blueprint for building machines that truly understand reality. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.